Kia ora and welcome to Aldehydes and Ketones, another episode in our schedule of organic chemistry. Alright, so aldehydes and ketones, they sound like fun. I will probably say them different ways all the time just because it sounds funnier. So, anyway, here we go. These are two of the new carbonyl compounds introduced in level 3 chemistry this year. Now, just a note to remind you that carbonyl means carbon double bonded to an oxygen, C double bond O. Okay, so both aldehydes and ketones have the general formula of CnH2nO. So they can actually be formed structural isomers of each other. So if you had a formula that was CH2O, then theoretically you can't actually have a ketone. So that was not a good example, Mrs. Hay. Try that again. C3H6O. You could have an aldehyde with 3 carbons, so the prop version of an aldehyde and a prop version of a ketone. So hopefully by now you've done lots of practice in nomenclature. You should know that that would be propanol and propanone. So they would be isomers of each other. Okay, so talk about nomenclature. Aldehydes, take away the E from the alkane chain and replace it with an Al. It's terminal function of group, so it is always at the end of the chain. That's what terminal means, at the end. If you're catching a train and its terminal station is Wellington, that is its last stop. Oh, examples. I was going to give you some examples there. Let me draw some examples. Okay, so pen. Oh gosh, where'd that one come from? Click on here. Yeah, my pen. Here we go. That's better. Okay, so examples are C double bond O H, simplest aldehyde you can have. This is meth and al. Alright, let's make one funkier. Let's go 3, like I just had before. This one is propanol. Let me put the hydrogens in because I'm going to be a good girl and do all my hydrogens just like you have to. Propanol. Now we don't need a number in here because propanol, it's always at the end, yeah? Let's get a funkier one. This time I might not do the carbons, hydrogens. Put the carbon there just to make it extra fun. So this would be propanol. Again. 2,2-dimethyl, 2,2-dimethyl propanol. Cool. Nice. Done. Next. Nomenclature for ketones. Take away the E from the end of the alkane chain and replace with -one. Position of the carbonyl group is given a number to locate in the carbon chain. Right, let's draw some examples of this. Let's make some up off the top of my head. The simplest one you can have, of course, is going to be this one. Okay, you can't have a ketone with 1 carbon or 2 carbons, yeah, because if you had 1 carbon there's no other carbons to attach it to, so you have hydrogen. So that would be an aldehyde. If you had 2 carbons, right, this carbon has to have an H, can't have another carbon. So this is the simplest ketone you can have. So this is propanone. Okay, now this is also known as acetone. And actually, out of curiosity and interest, in your book on page 134, there is a cool little list of some of the common names of these things. So there's things that you might have heard, like this one is acetone. Yeah, that's in nail polish remover. It's good for removing nail polish. That's why it's a solvent. It'll dissolve things. Okay, formaldehyde and acetaldehyde, you might have heard of those things as well. So that's also on page 134. Let's try another ketone though. Let's try one with 4. Oh, now, let's go back a second here. To be pedantic, you should say that this is propan-2-one. Okay? But of course, propanone, there is only one place you can put it, so it kind of has to go there. So you can just have propanone. But I'm being pedantic and I'll try and do that. So this is bute and 2-one. And again, there's actually pretty much, you can either go here or here, and both of those are carbon number 2, so it doesn't really make a difference either. But then if I start putting on, say, another carbon here, right, then that would be butane 2-one 3-methyl butane 2-one. Okay? Okay, making and physical properties. Right, so aldehydes are made by oxidizing primary alcohols. Now, last year, you would have found that primary alcohols, you would have said that they oxidize directly to carboxylic acids. But this year, I'm kind of saying that they go through the step of making an aldehyde first. The analogy I've been using in class with a few people is if I was going from Wellington to Upper Hutt, I would probably be driving through Lower Hutt, right? So it's a step on the way. Sometimes I might stop off in Lower Hutt and go do a bit of shopping at Westfield, but generally I might just kind of keep on going to Upper Hutt because my auntie and uncle live out there and I'm going to go visit them. But that's not to say that Lower Hutt doesn't exist, and I don't go through Lower Hutt to get there. So although last year you pretty much went Wellington to Upper Hutt, so alcohol to carboxylic acid, you have to realize that there is an intermediate step in there, which is the aldehyde. Okay, and this year we find that ketones are made by oxidizing a secondary alcohol. And a little note on the side there, of course, again, just to tell you again, that tertiary alcohols do not oxidize. Okay, physical properties. Short chain aldehydes and ketones have a similar have higher boiling points compared to the alkanes of similar molar masses. Now this is due to the polarity of these molecules and their stronger intermolecular forces. Now that might sit there and ring a few little bells in you. If I say intermolecular forces, some of you might go, ooh, that's van der Waals, and you'd be correct. That is indeed van der Waals. This year though, we break van der Waals down. Okay, break it down. You know, so we're going to break van der Waals down into the bits that make up those intermolecular forces, and one of those bits is hydrogen bonding. Okay, now this is noted down on page 134 again in your workbooks, but we're going to cover it more in Achievement Standard 3.4 structure and bonding. Okay, so if you don't kind of get that statement just now, don't stress, I will be going over it again later on. Just note that the aldehydes and ketones have higher boiling points because of the intermolecular forces. Right, moving on. Distinguishing reactions. Now this is quite fun. I do love this. This is one of my favorite things about aldehydes and ketones. Okay, so all these tests rely on the fact that aldehydes can be oxidized further to carboxylic acids and ketones cannot. So if you have, again, Mrs. Hay lost all the labels on her jars and she doesn't know what they are, and you have an aldehyde and a ketone, you can use these tests to distinguish between them. There is one that is my favorite, and I'm pretty sure you'll, by the end of doing this and doing the experiment, then you'll probably figure out which one is my favorite, if I don't say it already in class. Okay, so we could have acidified potassium dichromate or acidified potassium permanganate, and we have to heat that up as well. This one you should be familiar with. They are strong oxidizing agents. They are common oxidizing agents. You should be able to do those for Africa. Right. These ones should be new. Okay, so we have Benedict's or Failing solution, and we boil that. And we have Tollens reagent, and we warm that. Now, Benedict's and Failing solution, these are copper based. Okay, so these are Cu2 plus and Cu1 plus. No, just 2 plus. Let's just go with 2 plus. Alright. This goes from blue to brick red. Now the brick red is due to the fact that you have copper 1 plus. Ooh, I did it again. Copper 1 plus being made. Now the copper 1 plus, I can't stop writing too. Copper 1 plus is interesting because it doesn't hang out by itself. It combines with some hydroxide and makes some really cool funky stuff. But there is a huge nice definition and description on page 136, but you pretty much need to know that Benedict's and Failings are the same thing, and it goes from blue to brick red. You might have actually come across this before in testing for sugar, which is an interesting point which we'll come to later on. The last one is Tollens reagent, And our Tollens reagent is, I love this. I just have to write it down because it's hilarious. That is an AL. Ammoniacal or ammoniacal silver nitrate. I still don't know how to say that word. I can spell it, but I can't say it. It just looks comical. Get it? Comical to me. So this is silver nitrate that has ammonia with it. So it kind of forms this really cool funky S complex. And when warmed, aldehydes reduce the silver ions to silver solid. So you go Ag plus to Ag, Ag solid. By the way, this is the oxidation. Obviously, this is going from oxidation number +2 to oxidation number +1. So this is being reduced. This is going from +1 to 0. So it's being reduced. So yeah, you make silver. Kind of cool. All right. Again, there is a nice little discussion on that on page 136 in your workbooks. If you're not finding my brief description enough, if you want some more details. Last little bit of this. Reduction of aldehydes and ketones. So aldehydes and ketones can be reduced to primary and secondary alcohols respectively using the reducing agent commonly known as sodium borohydride, NaBH4. You don't really need to know how that process works or why that process works. You just have to know that it can be reduced. If you think about it, it makes sense. If you can oxidize something, what's to say you can't take that oxidized version and to reduce it back to what it was to start with. This one here is very common in exam questions, and people forget about it, so it's one that maybe you should take note of. Reducing aldehydes and ketones back to their primary and secondary alcohols. Okay? Cool. Right, so here's some exercise for you. Name the organic products formed in each of the following reactions. In some case there will be no reaction, so you have to write no reaction. So you've got methanol with Tollens reagent, propantoyl, you can go through that list. What I suggest you do is you pause the video now, pause, and start it again when you're done, because the answers will be coming up in about 5 seconds. Sweet. Now here are the answers. If you just went straight to the slide, shame on you. Nah, it's all good. Go back and do it anyway. It's good work for you to do. Alright, and here's another question for you. Identify by name and form the products of the reaction of the following compounds with sodium borohydride. This one I do not have the answers for on the slide. You will have to do this and ask me in class. Alright, I shall see you again soon. Ka kite anō. See you next time.